My dear students of 9th standard, nowadays we are discussing about the periodic classification of elements, unit 12. Unit 12 already have started, and we learned about the Dauber-Inner triads and the early classification of elements. The first scientist in 1817, Johann Wolfgang Dauber-Inner, classified the elements based on the ascending order of atomic masses in the group of 3. So this is called Dauber-Inner triads. Dauber-Inner triads, and there are limitations because you would identify only 3 triads, and this law was not applicable to elements having very low or very high atomic mass. Then next scientist, Newland law of octaves in 1866, John Newland arranged 56 known elements. At the time of John Newland, 56 elements were known in the increasing order of atomic mass. Also, he noticed that the 8th element had the properties similar to those of the first element, similar to the 8th note of octave in music. So this law is called Newland's law of octaves. Newland's law of octaves. Also example given in table 12.2. In 12.2, see that hydrogen, lithium, and like that, to say when we go up to 8 elements, the first element and 8th element having the similarity in their properties. Such a way he arranged the elements. But he would not arrange all the elements based on the property. That is one of the drawback of the Newland law of octaves. The next, now we are going to study about the important classification, that is mentally periodic table, mentally periodic classification. So in 1869, so you can open your book, take page number 139, and you should know to read. The reading practice is important. If you don't know to read correctly with correct pattern, you cannot learn and prepare for the examination point of view. So in 1869, Russian chemist Dmitry Mendeleev observed that the elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. So simply 3-4 lines you have to understand. What is the name of the scientist? That is Dmitry Mendeleev. What he observed? He observed some similarities of the properties of the elements when they are arranged in the atomic masses. He observed the elements having some similar properties are repeated at regular interval of time when he arranged the elements in the order of atomic masses. Then next, see what is the mentally periodic law. Mentally periodic law, these the 2 lines given in the pink color. The physical and chemical properties of elements are the periodic functions of their atomic masses. The physical and chemical properties of the elements are the periodic functions of their atomic masses. What is called a physical property, that are the volume and their the external properties. Chemical properties, how they are going to mingle with other elements to form a new compound. So these physical property and chemical properties are gradually increase, gradually changes, depends upon the or based on the atomic mass. That is the meaning of this periodic law. And how many elements were known at the time of Mendeleev? There were 56 elements at the time of Mendeleev periodic classification. Only 56 elements were known. So Mendeleev arranged 56 elements in the increasing order of atomic mass. So this is going to be a short form of periodic table. So nowadays, now we are having 118 elements. At that time, only 56 elements were known. So he prepared short form of periodic table. He prepared short form of periodic table. Then, what are the important features of Mendeleev periodic table? Question will be asked. The important features of Mendeleev periodic table. Mention the important features of Mendeleev periodic table. A list of the important features of Mendeleev periodic table. This type of question will be asked. So, only few points are given. You have to learn and listen carefully. The first point, it has 8 vertical columns called groups and 7 horizontal rows called periods. So, there are groups and periods. Mentally arrange the elements in the form of groups and periods. The question will be asked, what are groups? So, element in the vertical columns are called groups, and the element in the horizontal rows are called periods. How many groups are there? 8 groups are there. How many periods? 7 periods. How many periods? 7 periods. Then each group is subdivided into A and B. So mentally classified each group into 2 categories, A group, A subgroup, B subgroup, and the A subgroup elements having some similarity in their properties. Similarly, the subgroup of B elements having some similarity in their properties. Then, for the first time, the elements were comprehensively classified in such a way that the elements of similar properties were placed in the same group. So, apart from the Daubert triads and Newland law of physics, mentally arrange the elements in the increasing order of atomic mass. When he classify based on the increasing order of atomic mass, that comprehensive classification gives that the elements having similar properties placed in the same group. Elements having similar properties were placed in the same group. Then next one, the next property, it was noticed that certain elements would not be placed. It was noticed that certain elements would not be placed in their proper group in this manner. So the reason for this is the wrong determination of atomic mass. So Mendeleev corrected the atomic mass and placed in the correct position. For example, atomic mass of beryllium was known to be 14. Atomic mass of beryllium was 14, but Mendeleev reassessed the atomic mass and placed it in the 9th place and assigned the atomic mass of beryllium 9. Then columns were left vacant for the elements which were known at the time, and their properties also were predicted. So this gave motivation to experiment in chemistry. So Mendeleev gave places, Mendeleev left vacant places for the inclusion of new elements. He assessed and gave place. So because of this classification, this classification method also motivate the other scientists, motivate the other chemists to discover the new element which were going to be placed at the vacant place. For example, Mendeleev gave name for Eka aluminium and Eka silicon. So to those elements which were to be placed, aluminium and silicon respectively in the periodic table, and predicted their properties. So Mendeleev predicted the property of the element germanium. Before the discovery of germanium, Mendeleev left place for germanium by his determination. And see, after that, the discovery of germanium later during his lifetime proved correct that germanium discovered later on. When they are going to place the germanium, the place given by the Mendeleev, that position was correctly placed, that place was correctly fitted to the germanium, and this was one of the important uh, prediction of Mendeleev. So Mendeleev predicted some elements. This kind of elements are going to be placed here. Their atomic masses like that, the name like that, the formula like that. Those things were before the discovery itself Mendeleev predicted. So these are some of the important features. Then what are the limitations? Limitation means drawbacks. Limitation means drawbacks. What are the drawbacks of the Mendeleev periodic table? So here, elements with a large difference in properties were included in the same group. For example, hard metals like copper, silver were included along with the soft metal like sodium and potassium. So for example, if we take here, say in the uh, first group, and the first group, hydrogen, lithium, sodium, potassium. So sodium, potassium are soft metals. Sodium 22, potassium 13 is soft metal. But a copper, silver are hard metals. So these hard metals were given the place below the soft metals. Below the soft metals. So this is one of the limitation or drawback, demerit of the Mendeleev periodic classification. And also see the next point, that is no proper position would be given to the element hydrogen. So hydrogen always placed given in the first place, the first position in the periodic table, because its atomic number is 1, atomic mass also 1, but that place is not actually fitted to the hydrogen, because hydrogen is a non-metal. So this non-metal going to be fitted or placed along with the metals like lithium, sodium, potassium, and you are going to see the first column, that is see hydrogen, lithium, sodium, potassium, rubidium. See that lithium, sodium, potassium. So hydrogen is a non-metal, it's a gaseous state element, but that place is not actually for the hydrogen. It should be on the right side of the periodic table, but it is always given in the first place because its atomic mass is 1. Because Mendeleev arranged in the increasing order of atomic mass, that place only given for the hydrogen. That is also one of the drawback of Mendeleev periodic classification. Then the increasing order of atomic mass was not strictly followed throughout the periodic table. So some of the elements were wrongly placed. For example, cobalt, nickel, tellurium, iodine. Cobalt, nickel, tellurium, iodine. See here, when you're going to see here that the last column, CO, cobalt, nickel, Ni. Cobalt atomic mass 58.93, nickel 58.71. Actually, nickel should be placed before cobalt, because the atomic mass of nickel is less than the cobalt, 58.71. That should come first, then cobalt, but it is not in the correct order. This is one of the drawback. Also similarly, when you going to check tellurium and iodine, you can see that in the seventh group, see that is Te, tellurium 127.60 and iodine 126.90. So actually iodine should be placed before tellurium, because the atomic mass of iodine is less than the tellurium, but it is incorrectly given. So these are some of the drawbacks, demerits of the Mendeleev periodic classification. The next point, say no place for isotopes in the periodic table. So isotopic elements are there, that hydrogen, then chlorine. So these isotopic elements are not given separate place. All the isotopic elements are given in one place. So this is one of the drawback of Mendeleev periodic table. And the table 12.4 illustrate that the properties of germanium, how going to be coincide with the prediction of the Mendeleev. So Mendeleev prediction atomic mass is going to be 72. It is actually 72.5 nearly. Specific gravity 5.5, 5.47, that is equal to 5.5. Color dark gray. Formula, the determination of Mendeleev, that is ESO2. What is the formula of the newly discovered element, that germanium oxide? The nature of chloride, AsCl tetrachloride, the germanium tetrachloride. So more or less, mostly it is coincide with the prediction of the Mendeleev. So the Mendeleev left vacant places for the new elements which were going to be discovered later on. And also he predicted the atomic mass, specific gravity, color, formula, and chloride. So all those were predicted by the Mendeleev, which were more or less similar to the newly discovered elements. So my dear students, you have to go through the simple topic. What is Mendeleev periodic table, that Mendeleev periodic law, physical and chemical properties of elements are the periodic functions of the atomic masses. And in the futures you should know what are called groups, what are periods, and next say the futures are very very important. Then also say the demerits of the limitations of Mendeleev periodic table. Limitations, there are 3-4 points limitations are given. One example is also given, that is germanium. How Mendeleev predicted the germanium before the discovery itself. So this simple topic you have to revise. What is called a Mendeleev periodic table? What is the basis of Mendeleev periodic classification? That is the increasing order of atomic mass. How many elements were known at the time of Mendeleev periodic classification? 56 elements were known. And also what are groups, what are period. So all this you learn. And the next topic is a modern periodic table, that we will discuss in the next section. So complete your classwork and always revise up to discuss. So thank you. God bless you.